Welcome back. Announcements. Remember, you have an assignment 3. It's on Canvas. It's due February 15. Diagrams, basically, use cases, class diagrams, 2 questions, something easy, individual assignment, so do not forget to submit. Also, today, another quiz, the weekly quiz. By the end of the lecture, it's going to open on Canvas. You have all day, due date tonight. When we finish the lecture, you can go and complete your quiz. As usual, 10 questions, half an hour, open book, just to be sure that you are up to date regarding what we are reviewing, particularly this quiz, classes, relationship between classes. Be sure to review that before starting the quiz. I am not sure what are you trying to say, Evencio. I am sure that you are having fun, but please. Quizzes, there are going to be quizzes that are 24 hours. The last ones and the one today is just half an hour, something quickly, just for review. Good? So quiz and assignment, don't forget, please. Moving forward, previous class. Finally, we're working with these classes and source code. It's going to be a key part of your exams. A lot of the exam is going to be related with this. The fact that you can connect requirements, design, and the product, the software. We have been working with this design of the Pac-man. We start with this, use some boxes with some ideas that basically come from the requirements. We move forward in the previous class to source code. I explained to you every single class and the lines there, and hopefully you have opportunity to play with the code, maybe copy paste this to a project in your computer and run the project. Be sure that every single thing here is kind of clear, makes sense, but the most important thing is all the things here in the source code correspond to one thing in this class diagram, the last picture that I showed you before. When you look at this class diagram, it should be easy to understand now how each of the things are connected and what do you need to do to accomplish each of those relationships. Why this one is use align, why this one is with dots, why this one is a solid line with the triangle, why here we have the diamond in black connected with the down before. All those kind of questions, why these lines are different and what they represent, not only in the big picture here, but also in the source code that you have. Hopefully that is clear. The tricky part here, the maybe most difficult to understand, is why in somehow way this maze is solid, but also this maze have this white. And the game is the owner of the ghost. The game is the owner of the Pac-man with this black diamond that imply that one cannot exist without the other. But at the same time, we have this maze that have the diamond with drawables, which include the Pac-man and the ghost. But it's not black, it's white. And hopefully you remember here is the passing of parameters that we implemented before. That which our solution was, I am the owner of the computer, I am the owner of the item, but I am going to borrow you that item, the Pac-man and the ghost. And then you are going to be able to work with them, be the owners by aggregation, even though I am the one that create them with the new. That relationship exists between game, maze, and ghost. And I do not care about you understanding the game or being able to implement the Pac-man video game in particular, but that is just the example of how things can be connected. Now, hopefully you have the big picture of the source code and the diagram, and then I can ask you questions about new things to do with this. Moving forward now. Having this source code and having this diagram, the next thing that I want to do is to ask you for the score in the game. I would like to have a score, and that score is something that I would like to print there. And what is going to be the rule? I don't know. Every time that the Pac-Man and the yellow and the red have a collision, I am going to give points to the Pac-Man. It's really not relevant. It's just increase a variable, but I would like to have the variable on the screen. And every time that they have a collision, I get 10 points. Okay. You're going to draw diagrams in the exam? No, you're not going to be able to do that. Canvas do not allow you to do that. However, you're going to have diagrams, and the question is going to be which of 2 or 3 options is the correct answer, or you're going to have a diagram and the questions are going to be which relationships are showing that diagram. So you need to understand diagrams, even though I am not going to ask you to draw the diagrams, not for the exams, but in the assignments. When is the midterm? Well, your midterm is around the week 8. Remember, you have only one midterm. We have 16 weeks. So around the week 8 or 9 is going to be your midterm. That is the first or second week March. So I am going to tell you more in the next weeks. I am going to tell you about the midterm at least 2 weeks before. So we're going to start talking about that in 1 or 2 weeks. And then in 1 or 2 weeks, you are going to have the exam. Good. That number is the score. Just take the screenshot, and that is my current score. Well, the score in the moment in which I took the screenshot. So, score. So what if I ask you to add a score for this game using the classes that I shared with you in the previous lecture? It's like, what do we need to do in order to have a score? And maybe I would like to start with the class diagram. What could be something that we can do in order to add this score? Can we reuse something that we have here? Do we need to do something from scratch? In which class do we need to work? All of them? Some of them? One of them? One? Which one? Ideas. Okay, I like that idea. Let's see. The score should be in the game, just like the Pac-Man and the Ghost and the pills. And a key idea that you mentioned is the score can be drawable. The score can be just like those guys. I mean, so far, the Ghost, the Pac-Man, they are moving. But the power dot is not moving. It's a rectangle on the screen. The only thing that I am asking now is, well, instead of a rectangle, it's going to be a group of characters, a group of numbers that are going to be drawn on the screen. Could you agree with that idea of score? Another class that implement drawable. Another class that is going to have a draw method. Another class that is going to have attributes, but maybe instead of use position X and Y, well, for a score, I will need X and Y. I need to put the score in some place, but probably I could have also value. I don't know, just playing with ideas. Another variable, and that variable is going to change. The X and Y are not going to change like the Pac-Man or the Ghost. The one that is going to change is value. Someone is going to modify the value in the same way that someone modified the position of the Pac-Man. I am going to provide methods in a score to be able to update the score. but I don't care who is going to update the score or how the score is going to be updated. It's just a new class with all the characteristics that we had before with the others. Now, we have already connected this drawable with the maze. Can we reuse that connection? That we assume now that just because we create another child for drawable, can we just know that now maze have Pac-man, Ghost, Power Dot, and also scores? Just because we add a score as a new option for drawable. Makes sense. And still, we have this connection of the maze with the game. Just by adding the new class and connecting the new class with drawable, I do not need to do any other thing in the structure. Obviously, the score needs to be updated. That is a different story. But regarding the classes and the methods and the connection with the things that I have before, only this, and I am in. I have a new element. Okay. According with that idea, let's see a little bit of the source code. You are asking me to create a class score. You are asking me to connect the score with drawable. Connect that class with the implements. And according with the idea that you described, 1, 2, 3 variables. The position of the score. I want the score here in the corner, in the right left, in the right top. So 440, that is going to be the position for the score. I could use a constructor here and pass the parameters for the position. That could be better. Just to save some space, my constructor is empty. My values are out. The position for the score. The important part is this variable, the score itself. It needs to have some kind of value, 0. And then I need a public method. I need a public method that is going to give me access to the score. I do not need to decrease the score. So far, I do not remember rules for that. I am going to increase. And for this example, I am going to increase in 1, so use score plus plus. You are going to increase the score in 1 every single time that this method increment is called. Who is going to call that method? I don't care. That is the work of someone else. My work as a score is to provide the interface, the method, for someone else to update the value of the variable. Moreover, my work as a score is to provide the storage for the value. And finally, because I am implementing this interface, my responsibility is to provide an override of the method draw. Just like the Pac-man and the dot and the ghost, I need to provide that method. It's something that I need to do because I am drawable. For that, my responsibility includes the score is going to be in blue color, set color. Before was yellow, gray, white. Now it's blue. And draw something. For the Pac-man and the other elements, draw rectangle, draw rect. For the score, we have a method draw string. Draw string is write something on the screen. Draw text on the screen. Draw a string. This string, the value of the score in these coordinates. For the rectangle, X and Y, and the size. For the string itself, and the X and Y of the beginning of the string. Okay. So, as you mentioned, and this is just to play a little bit with things. Yeah, I make this static. I need to talk more about the static and more about how to play with this. Right now, to be honest, for the solution of this, that variable could be static or not. It's not going to make a big difference here. It's going to make a difference later. We need to talk about patterns. We need to talk about why it's a good idea to have a static here, but it's a different story. Right now, the only thing is I can make that one static or not. Nothing happened. What I need is the variable, the public method, and modify the draw. Done. That is a score. The variable, the draw, and modify the value. And this class is connected with the others that I have, just with one instruction. That instruction put that class together with what I have before. Okay, now, what else? Well, what if you want to do something with the score? What if you want to, for instance, increase the font of the score? What if you want to have this number bigger than before? Because in the previous example, the numbers were small, hard to read, whatever. If you have a requirement about increasing the size of the font, which class do you need to modify? Moreover, which method in which class? And hopefully you agree with me. Well, if you're asking me to modify the size of the font for the score, I need to modify a score. Moreover, if you're asking me to modify how the score is going to be drawn, I have an idea of which method is the one doing the draw. Class score, method draw, and you're asking me to play with the size of the font. There should be something there for that. Well, do we have that? Can you explain me what is happening there in the lines 19 and 20? It looks like familiar. Hopefully, yes, because basically 19, we're creating an object, a new object, whatever that object is. It's an object from a class font. So it's an object that is going to represent one font, and that font have a name, the name of the font. I want to use Courier New. I want to have a particular size, 36 points, and I want to use a particular style. You have constants for this, but you can imagine plain, bold, italic. They are constants. You can use the numbers 1, 2, 3, whatever. It's an object. The object represents the same thing that happens when you select a font in your PowerPoint or Word or whatever. When you select a font, really you are creating an object. The only thing that we need to do is to ask the graphic to use that font, to set that font as the one that is going to be used for whatever you do from here down. So if in the line 21 I am printing something, I am going to print that something with what? With the font that I am defining I want to use in the previous lines. Create an object, set the object. The object is going to be used for the activities that are related with that object from that point down. It's the same thing that happened with colors. So far, I have been playing with this idea of set color, and inside of set color, inside of the parentheses, I am giving you a constant, color.blue, color.red, color.yellow. However, the key idea here, color, is a class. You can create an object. How many parameters do you think we need for the constructor of a color? I like that idea, 3 or 4. Why 3 or 4? Well, what do we need to create a color? For the computer, the easy thing is do we need a number for the red, a number for the green, and a number for the blue? In the computer, the colors are a combination of those 3, right? At least that is what we do to represent them. And optionally, we can provide an alpha value. The alpha value, the transparency, right? Yeah, we can provide numbers. And remember, Java support integers, octals, hexadecimals. So what we need is here at least 3 parameters. I am not going to play with the alpha, so 3 parameters, red, green, and blue. Those parameters are integer values. Those integer values can be represented in a decimal format, octal, hexadecimal, even binary if you want. Let's play with the decimals. What could be the value? Thank you, Vencio. 0 to 255. Why 0 to 255? Is 1 byte. The smallest number in 1 byte, the biggest number. Everything in 0, everything in 1. So you represent a color just like that. What if I put here 0, 0, 0? I am creating a new color. Well, that one is black. What if I put 255, 255, 255? That one is white. You can play with any combination in the middle, and basically you're going to create a new color. By default, the Java API gives you these constants, so you do not need to do all the process of creating a new object for colors that are common, like the blue. But if you want a crazy color, you can create it. Now, I create a new color. What I do with that? G dot set color. Just like the set font or the set color that I used before. Now, instead of using this constant, the object, you create the object, you establish that object to be used, and that object is going to be used for whatever you have done. In this example, that crazy color is the color of the letters that you're going to print with the font that you define. Creating objects, applying objects, and your program continue relationships. Now, working with the class diagram. Question for the exam is like, right now, you are working with a class here, score, but also you are using a class color because you create a new object color, and also you are using the class font. So in the source code that you are showing me, you have these 3 new classes. I need to connect these classes with the class diagram. You already know that I am connecting score with this realization relationship, score with drawable. My question for you in the exam, there is a connection between a score and color. And if yes, which is the connection? And you already know the options. Connection between a score and color, yes or no? In the source code that I showed you. Yes, no, maybe. Yes. Which relationship? Do we have inheritance, association, composition, and so on, using. What do we have? We're creating an object, right? We're creating a color. Local or global? Local, right? So what is the relationship between the class score and the class color if score is creating an object local? Option A, association. Option B, composition aggregation. Association. Local variable, association. If you think about the diamonds, if you think about composition or aggregation, remember, those work with global variables, not with local. It's a common error. So color and score, there is a relationship, is association, because we create a local variable and we use that variable in a method. So local relationship, association. And the same is going to happen with font. And obviously here, probably I will put color and font in a blue color. They are classes from the library. And I could put score in yellow. There, that one is a class that I am developing for my program. So those are our new relationships here. Good? Clear? What if I ask you to, you know what? Now I want to do something else with the Pac-man. I want to include this table. I want to include the best scores, the 5 best scores. Because now I am keeping track of the scores. Somehow I would like to add to the game this idea of having somehow access to the good scores and, well, to the name of the player that made those scores. So I have this new space in which I would like to display something like this. My question is, what do I need to do? And obviously, as a programmers, you're thinking about the source code that you need. If I ask you to do this as a project, obviously you need to think about the source code. But I want you to stop and instead of thinking directly about the source code, can we think about the classes? We need new classes, either classes that we are going to create or classes that we're going to use from the libraries. There are going to be new classes involved. How those classes are going to be connected with the classes that already exist? What if I told you that in order to display this, something that I would like to have is a menu bar. And in the menu, well, at least one option to start the game and another option to check the scores. So 2 options in the menu. I am asking you to create a menu, and I am asking you to deal with selection of one option or another option. And the second option is going to display this. And this maybe is going to be a dialog box or something like that in Java. Just by describing that, I am talking about the class menu bar. I am talking about the class menu item. I am talking about the class JDialog box. 3 new classes. They are going to be connected with my class diagram. How, right? Just to give you an idea of the specifics. What if I want something like this in my particular game? So we are back to our graphical user interface, menu item, with something in particular, file, with these 2 options, save and show. One is going to save this number, the other is going to show me all the things that I have saved before. when I choose this one, the show, I would like to have something like this. A dialog box, the number, the name there, if there is any, as many as scores I have saved. This example is with one, maybe more. And obviously some way to close the dialog, right? Either this one or this one, but the dialog should close so I can continue playing. What should happen to our class diagram and the source code to create this and this? What do you think about this diagram? What if I told you that, you know what, these are your requirements, moreover, your source code should match this diagram? Can we understand what are my instructions in the diagram? What you should do in order to accomplish the requirement? What is that one? Score table. What is going to happen, or what is that class? Could you agree with me that that class is something that probably I am using to create this? It is clear to assume that, well, that one, the one with all the scores, is probably going to be this one. Moreover, makes sense to think that that one is going to be connected with game. It's not connected with the Pac-man or with the maze or other things. It's connected with the game. The game is the one that have that one. Moreover, it's connected with a diamond. The game cannot exist without the table of scores. At least that is what I am defining, that the table of scores is going to be mandatory because that black diamond. One connection, one class, one object. That guy is going to show me the scores. Now, the scores is a table. I need to save the data, right? And because I need to save the data, I need to use a database or a file or something, whatever. Did you notice the first attribute in the class? When you read that one, that first attribute, I want you to notice one particular thing. The name of the attribute is file, and all the letters are uppercase. Do you remember what is the meaning of having an identifier with all the letters in uppercase? It's a constant, correct? It's a constant, and well, if you notice, the name of the constant is a string and the name is file. It's going to be the file in which we're going to store the scores. We're going to use a file to store the scores. This class is going to have two responsibilities. This class is going to be the one storing the scores, retrieving the scores. And why not? Showing the scores on the screen. Say, load, show. One class. Everything about the scores table in one class. And that class is a delegate, is connected with game. At least that is my design. That is what I want. What is this? The interface serializable. This is something that hopefully you learned before. use a small summary. When you have an object, like we have a score, and we want to store that object in a file, what we can do is to serialize the object. You can have a file that have only store the numbers, the scores, or you can store the full object, the score. Here, to be honest, just to play with the libraries, I am using serializable with the score, and I am going to store the full score, which basically means that I am going to store not only the value of the score, but also the coordinates in which the score live. So all this information in the file. It's not the best solution for the Pac-man, but give me the opportunity to introduce serializable and something that I can ask you to use later. When I read in my diagram that score is implementing that interface, I am sure that the score is going to be saved. I am sure that the score is going to be used to store information, not temporal, not only in the RAM, but it's going to be used to store the information in a file, in some kind of persistent place, because that is what the interface serializable gives me. So the score now is serializable, and my score table is the one doing things with the score. And I want you to notice this. That one is going to be connected with the score, and hopefully makes sense for you to think about, well, yes, if that one is going to be storing the score, and that one is going to be retrieving scores, and that one is going to be showing scores in the screen, that one is fully connected with the score. Somehow they need to be connected. There is going to be a line between them. The only decision is, well, it's going to be used a line with diamonds, or a line with triangles in inheritance or something. Here, diamonds. But there are two diamonds. Why? Can we have these two classes connected with diamonds, in this case, two relationships between the same classes? What is the meaning of having one class A connected with a class B and two relationships? We need to remember what does it mean one relationship. Each relationship represents a variable, a global variable. Can you agree with that? For each diamond that I have, one diamond, one diamond, one diamond, the diamonds represent, well, I have variables score, I have variable goals, I have variable Pac-man. Here, what I am representing in that diagram is, I want to have two variables scores. Somehow I am going to use a score 2 times for creating my class. Yes. Public class score table. Something that I maybe want to have here is private score, an array. That is the source code for the diagram. I am using a score 2 times, so 2 relationships. Why 2 times? Well, this class, remember, is the one that is going to read and write in the file that have the older scores, the scores from previous players. So maybe makes sense that if in some point I am going to recover those scores, I can read the file and put those scores in some kind of array, an array of scores. Therefore, I need a variable that is going to be that array. It's going to be empty at the beginning, but in some point, I am going to have a method, public, read the scores, maybe. And this method is going to do something to read data and put that data in that variable. It's an aggregation. I have the variable, it's null. In some point, if I call the method read, I am going to add values there, just like the car with the wheels. Null in some point, then I can add it. Score, the array, one relationship. In a different relationship is I have a score that probably is the score of the current player. Whatever the current player have as a number on the screen, that is the score of that player. What I am going to do is in some other method to compare the score of the current player with those scores in the array. And if the current player have a better score than the worst score in the file, the current player is going to replace those that I have in the file. Assuming that in the file I only have the top 10 or the top 5, whatever. That is the reason because I have two variables, both score. One is an array, the other is not. My class diagram should show me that, two relationships. Makes sense? Questions so far, guys? Fine? Silence. Hopefully that is yes. Okay, let's talk about an assignment, something for you to do. Following the same idea that I showed you with the Pac-man. The same idea for the class diagram, for the programming. I would like to ask you to solve something like this. Another game, yes, another game. I have this game, and hopefully everyone knows the game, so I do not need to explain the rules, right? Yes? Silence, so that means you do not know the game. Okay, quickly. Yes, you know the game, okay, space, yeah, please. You can Google Space Invaders, and yeah. Good. Quickly, what I have here is 1, 2, 3 elements. Those 3 elements do not move. Those 3 elements are kind of the power pills that we have before. 3 things that you put on the screen, they do not move, right? You have one element that is the one controlled by the player. It's like the Pac-man, but this one just move left and right. You do not move up and down. So in that regard, is simple than the Pac-man. And you have elements, a lot of them, that are just like the ghost in the Pac-man. They move. They are, instead of just 4 ghosts, they are more. With the good news that instead of being smart, like the ghost in the Pac-man, these guys, as you know, they are just moving in a very predictive way, right? Just similar to this one, left and right, and in some point down, left, right, in some point down. You know the rules. So one element that the user move, just like the Pac-man. 3 elements that never move, just like the pills. A lot of elements moving in a particular way that is controlled by the system, not by the player, automatically. And score. Let's use only one score, the score of the current player. Same elements that I have before for the Pac-Man, right? The enemy, the player, static elements, and a score. Can you think about the class diagram for this game? Which are going to be the elements in the class diagram? And I am thinking about the classes that you need to create. We're going to have a class game. Do we need a class for this guy? Do we need a class for these guys? However, notice that we have different guys. There is going to be inheritance there, maybe, the enemy, and we have different specializations of enemies. All of them have a draw method, or should have it. They are on the screen. Do we need the drawable interface? We can connect all of them inside of game. What about the score? Do we need a class score, just like the one that we created before? Key listeners, talking about the elements from the Java library, panels, JFrame, the elements that I described before for the Pac-Man, the list of the classes that you're going to need, I am sure that you are going to figure out. Moreover, the connection for those classes, how they are going to be connected. Is the same or similar to the one that I showed you for the Pac-Man? Probably similar, not the same for sure. There are a small difference here that are going to affect the class diagram. Moreover, after the class diagram, what about the source code? What about the implementation of the game? Because implementing the game, making these things move, and allowing the score to increase, and handling this element that I have here, the shooting thing, what are we going to do? Do we need a timer, like the timer that we have for the Pac-Man? Can the timer help me to do both things, move these guys, but also move this guy? What about the collisions? Where do we put a method for checking the collisions between now this and the enemies? Because now it's not about the Pac-Man and the ghost. It's not about this chip here. It's about this thing that is going to be moving. I am concerned about two things. What are you going to do to make this game work in Java with Java Swing, but also about the class diagram? For the assignment, two things that we're going to grade. Number one, obviously, that the project work. We're going to compile and run your game. We want your game to be working. You are able to do that. The second, equally important, we need to review that your class diagram match the source code that you submit. Common error, guys, and I want to tell you this very, very clear. If you submit the source code and your source code work perfectly, you can get the source code from the internet. And you submit a class diagram that do not match the source code, the relationships, the variables, even the name of the classes, you're going to receive 50% of the grade. The class diagram is very, very important. The class diagram shows me that you understand the design and the implementation like the same thing, like being connected. So please double, triple check that your class diagrams match the relationships in your source code. Which one? This one. This is your assignment. The Pac-Man, I already give you the implementation. The Pac-Man is just my demo for you. This is the game that I want you to implement as an assignment. To be honest, hopefully you have the opportunity to review the Pac-Man before. Hopefully everything that we have reviewed with the Pac-Man is clear for you, because this one is just a small modification of the Pac-Man. Think about it. Removing the maze, having these guys less smart, the collision now with different elements. they are related. Yes, you are right. This is your new assignment. When is due date? The due date, 1 week. That is going to be as usual. 1 week for you to work in the assignment. This time, I am asking you to work individually. So this assignment is individual work. I really want to check that all of you, each of you, is moving forward with class diagrams and that you can do some programming using these elements. One requirement, one non-functional requirement, please. For the graphics, use Java Swing. Can we use Java effects? No, use Java Swing. My non-functional requirement for everything that is graphics, please follow the Java Swing. Use the Java Swing library for the graphics. Can we use other libraries for the graphics? No. For data structures, you can use collections. For input and output, you can use Java EO. For other things, you can use everything available in the Java API. For graphics, please, everything that is graphic, Java Swing. Yeah, that is correct. Very good question. What about the details of the characters? You do not need to do the draws exactly like this. I mean, I did the Pac-man just like a square in yellow. So you can follow similar approaches. I want these guys to be different, but I don't know, you can draw an X and a circle and a triangle, up to you. I mean, you're going to create inheritance. You're going to have 3, 4 different draw methods. Draw something different, but you do not need to draw exactly what the game has. Well, you have this assignment that you're working right now that is basically 2 diagrams. To be honest, guys, I give you 1 week just to follow the standard. But that assignment, the one that you're working right now, the 2 diagrams, you can finish quickly in 1 day, 1 hour. It's just to be sure that you're moving forward with the diagrams. So that one is that one could have been a quiz, but I didn't put that as a quiz just to give you the opportunity to have more time to review things. So yes, you have that assignment running, the one that is 2 diagrams, the use cases and the class diagram. It's a very, very simple one. This is the important assignment. This is the complicated one. This one needs more time. My recommendation, finish the previous one as soon as you can, so you have a full week with this one. Yes, you have 2 assignments that are kind of running together for the following days, at least for the weekend. Yeah, you have 2 assignments. That is a very good point. It's how many lines of code is going to be this assignment? Five, 25, 66, 65, 95, 125, 150, 200, score 225, 250, this one, my Pac-man, 300 lines. This game, the same. You're going to implement the moving and the inheritance and other things. Okay. I think that worst case scenario, you're going to do 400 lines of code. I am thinking worst case scenario. And I mean, you're going to use a lot of open, closing curly brackets in different lines and so on. I think 400 lines could be the top. I don't know, really, depending on your programming skills and style. So less than 1,000, hopefully. Good. So the text file for the Pac-man, I really would like you to copy the code. My intention is that when you write the code from scratch, that is the reason, because these are images, not PDFs, text, is by writing the code, probably you are getting a better idea, taking time of kind of think about what are you writing. So I would prefer you to copy the code, transcribe the code, instead of giving you the source code working. But if you have any problem, like I already copy everything and it's not working, send me an email and I could share with you the files. But let's think about that like your second option, not the first one. So second option, if you are not able to make the Pac-man work used by copying the code from the slides, send me an email and I could share with you the project. Good. But again, second option, not the first one. So this is your assignment for programming, individual. Any other question about this? Okay. Well, the instructions are this. What I am going to do is to pause the video so you can watch the video as many times as needed, nothing else. I am going to open the link for the submission after the lecture. So tonight you are going to have a new link there with the instructions for the submission, individual submission. I am expecting a PDF, source code, the PDF with the class diagram, the source code Java for this, all your classes. There is not going to be anything new there. Regarding the code and the diagram, guys, my intention is, hopefully, that you have my requirements, my idea, the picture in the slide. Hopefully you do the same thing that we did with the Pac-man. Start working with a design. The first thing that we did is these blocks that represent the classes. And we start with this idea of which could be the boot connections. And then we move to the programming. And we do some programming, and in the middle of the programming, we figure out that some variables should be local or global, or some relationship need to be improved. Iteration, remember? You can go back from the programming to the design, fix things, add new classes, new relationships, whatever. Go back to the programming. This is going to be an iteration. So we are going to review that your class diagram, your program somehow match. The worst thing that you can do is finish with the programming. And after you have the software, do this translation, quotation marks, translate the code to the diagram. It could be a bad idea. It's not the process that you should follow. Moreover, you can make mistakes. And yes, worst case scenario, if your source code do not match with your class diagram, probably there is going to be a rubric, but probably your score can go down to 50%. That basically represents that, yes, your game works, your game is great, you are a very good programmer, but that source code and the diagram do not match. Again, the worst case scenario is that you get the source code from the internet and then you do this class diagram that do not really represent what is in the source code. So yes, please, source code is important, should compile, should run, but remember, what we are reviewing here is software design right now, class diagrams, how to do the design and the code and keep them connected. Yeah, the quiz today is about classes, objects, and their relationships. So class diagrams is going to be something about inheritance, realization, composition, association, and so on. Be sure that you review the source code. Be sure that you know which source code corresponds with which relationship. Today, the quiz is going to help you to check which things I am expecting to read in your class diagram for the project. Yeah. Well, okay. Hopefully you do not really consider that this is 1,000 times more complicated than the Pac-man. Again, guys, hopefully you notice is almost, is very similar. Use that, very similar. The differences are in the details, in the content of the method. There are going to be obviously differences, but thinking about the structure, the connection of the classes, this is the more similar game that I found in order to explain one and ask you for a different one. Lectures, the previous ones, you can review the previous four, the previous 2 weeks. That could be a good thing to do before the quiz. Yeah, there is not a concept of lives, just like in the implementation that I did for the Pac-man. You can continue playing forever. So, good. My concern is for you to use the timer class, you're going to need it. For you to use listeners, you're going to need it. And all the relationship between classes match with your programming. Those are the things that you need, basically. Java Swing, frames, panels, that could solve everything. And even you can do these graphics here, the details. Again, I am not asking for the details. You can play with that. Review the class graphics. All the methods that you need for doing fancy things are there. But again, use with the rectangles and circles and lines, you're going to be fine. Good. Any other question, guys? These are the details that I am going to share with you on Canvas. Again, class diagram, the requirements, the source code, the 3 things that we have been reviewing. Now I am going to ask you for these 3 things for the project that I just described. And that's it. So I am going to stop here. You can start working with your quiz. You have some time, 5 minutes, so you can start with that, or you can complete your quiz later today. Good? Any question, guys? Okay, see you next lecture. Thank you.